Hello everyone. So today we'll be going to speak on the topic RPM counter. Let's start with the introduction. Hall effect sensor works on the principle of the Hall effect, which states that whenever a magnetic field is applied in a direction perpendicular to the flow of electric current in the conductor, a potential difference is induced. This voltage can be used to detect whether the sensor is in the proximity of a magnet or not. Arduino can detect this voltage change through its interrupt pin and determine whether the magnet is near the sensor or not. So the Hall effect sensor has three pins basically: the VCC pin, the ground pin and the Vout pin. The Vout signal is connected to pin 2 of Arduino board. Whenever a magnet moves past the sensor, it will be able to detect it. Magnet can be placed in one of the arms of the fidget spinner. Whenever the magnetic arm of the spinner will pass in front of the Hall effect sensor, the sensor will produce an output which will be connected to the Arduino board. In this way, we can measure the RPM of any rotating arm. The following setup behaves as a tachometer. So what got us motivated to do this project? The driving force in doing this project was to optimize the design and increase the efficiency of the currently used setup to measure the RPM in various mechanical components. While implementing this design, we also look forward to focus on optimizing the overall cost to manufacture and making it as minimum as possible. In the end, we will be coming up with a self-contained and highly robust, at the same time being highly compatible in the different domains of mechanical and electrical machines.
Hello, I'll be talking about the problem statement that we are going to solve through this experiment. So, in the industries, the tachometer which they are employing in the automobiles and different machinery is very large in size. So the main problem is making the device much more smaller, portable and accurate so that it can be incorporated in much smaller machineries. The literature survey that these are the papers that we went through during the course of this self-study. The first paper is Hall effect sensors design, integration and analysis. So the advantage of this paper is that sensitivity can be varied by changing the Hall cell dimensions. Operating temperatures are very high, so 0 to 90 degrees centigrade is a very high temperature to operate this sensor. The only disadvantage that this paper offers is that complexity and the cost of the system is increased due to implementation of the CMOS tech. Next paper was position measurement with Hall effect sensors. MRL Hall sensors is used for detection in this paper. Response rates are very good and this is an advantage. The only disadvantage is useful measurement range is 1 mm and 16 mm and can be varied, but sensitivity takes a toll, so we are not bothering much about sensitivity in this paper. Next was microcontroller based temperature monitoring and control. So this is mainly for LCD brightness. In this, the detection methodology includes the two fixed resistor and a variable resistor are used to adjust the gain. So mainly it incorporates the potentiometer in that. The advantage is use of amplifier to reduce offset and low pass filter to eliminate noise is implemented easily. So in this paper will also contain elements of digital signal processing and incorporation of various low pass filters for a good response. This paper offers a disadvantage, and that is that resistor need to have small tolerance for better accuracy.
So I am going to explain about the methodology, i.e. the working of the model. We are using a Hall sensor over here which works on the principle of Hall effect, which states that whenever a magnetic field is applied in a direction perpendicular to the flow of electric current in a conductor, a potential difference is induced. This voltage is used to detect whether the sensor is in the proximity of the magnet or not. The Arduino can detect this voltage change through its interrupt pin and determine whether the magnet is near the sensor or not. So the things which we need to take into the consideration is that the magnet should always be on one of the arms of the fidget so that the RPM can be measured. The detector of the Hall sensor is placed near to the shaft. The VCC and the ground pin of the Hall sensor is connected to the Arduino's 5 volt and ground respectively using the wires and the jumpers. We will be using the timer 0 of the Arduino for this project. So the working of the model. In the model we are using a Hall sensor. The Hall sensor will detect any change in the magnetic field per second. There is a LED on the breadboard which will be showing a IE detecting any change in the magnetic field. The readings are taken up by the Arduino and processed into the laptop by using the Arduino code which is shown on the monitor. This is a block diagram. We are using an Arduino Uno board and a LCD panel which will be displaying the RPM reading and a Hall sensor 3144. This is the picture of our model. Now I will be explaining how the model works. So this is the Arduino code which we will be using. First, we go to the tools and we open the serial monitor. Then this Arduino has been connected to the laptop which is powering the Arduino board. This serial monitor will be showing any change in the RPM reading. Maximum RPM has been set to 240. This is the magnet on the fidget spinner detected by the LED via Hall sensor. Now, the calculation of RPM. You can see how the RPM is changing. The change is being detected by the Hall sensor and processed into the Arduino, and LED is confirming it.
So we've learned the following from the above project: working of Arduino and understanding of the code, involvement of Hall sensor for RPM calculation, as whether a magnet moves past the sensor, it detects it. The presence of magnetic field is indicated on the LED. We have made a simple RPM calculator using Arduino, LCD, variable resistor that is used to change the brightness of the LCD, and Hall sensor. The LCD also indicates the current RPM and the maximum RPM. Applications: the sensor can be used as a position sensor for linearly moved or rotating objects. The main areas of application of these devices include speed measurements, as in speedometers, frequency meters, tachometers. It's also used in flow rate sensors, proximity sensors, magnetic card readers, door interlock ignition sensors, and the rest of them are mentioned here. The following references has been used to complete our project. The following table links it to the respective subjects. The hardware development programming for Arduino links it to Verilog. The Arduino acts as a microcontroller which further uses an ATmec328 processor. The Hall sensor being used is directly indicated of sensors and instrumentation subject. This presentation is presented by
Kshitij, prashar,
Mudit, sharma.
Madhul, Mayank.
Talin, mittal. Thank you.